Hello guys, this is Syed Mohammad Waqas. I'm back with another video. In this video I will tell you guys how to calculate the overall heat transfer coefficient U value for the wall, for outer wall and for the inner wall or partition walls. So let's start. Let's say we have a building where outside wall composition is given as this. That building consists of combination of different layers, that is 230 mm common brick plus air space plus 230 mm common brick and 26 mm, that is 13 mm both sides sand cement plaster. So as you can see in this figure, if you will see, this K1 is basically representing as our brick 230 mm. This H0 is over here representing as the outside film coefficient. Then we have a Ka, that is the air space over here or air gap over here, and then we have K2 representing the second brick over here, that is 230 mm. Then Hi is the inside film coefficient. So this is the general formula which we basically use to calculate the overall heat transfer coefficient U value. So as you know the composition of the wall, so this is the thermal conductance values which are given over here. These values you can find most probably in ASHRAE Fundamental 1997 or any version. You can find the thermal conductance values. So you just need to pick these values and then calculate the overall heat transfer coefficient. So let's say we have this building composition, outer wall combination. Then thermal conductivity of the brick is given as K brick 0.77, thermal conductivity of plaster is given as 8.65, and thermal conductance of the air gap is given as 5.8. Outside film coefficient is given as 23, inside film coefficient is given as 8.5. and this x1 and x2 values, x1 is basically 13 mm over here. As you can see, 13 mm is the sand cement plaster on both sides of the brick. So in order to convert this into meter, you need to divide by 1000, you will get 0.013. So x2 is basically the thickness of this brick, that is 230 mm. In order to convert this into meter, you need to divide by 1000, so you will get 0.23. So these are the thickness of the plaster. X1 is the thickness of plaster, x2 is the thickness of the brick. So as you see, this is the formula which we are going to use. This is general formula: 1 divided by 1 by H0 plus x1 divided by K1 plus 1 divided by K plus x2 divided by K2, so on up till 1 divided by Hi. You know that this H0 and Hi are the outside and inside film coefficients, and this x1 and x2 already explained you. These are the thickness of the plaster and brick. So if you have any insulation material or anything is added in your wall, you need to add these values to get the overall heat transfer coefficient. So this is the formula, 1 divided by H0. So if we are going to put the values over here, so 1 divided by 1 by H0, H0 is given as outside film coefficient is 23, so we have used 1 divided by H0 is 23, plus this the second, if you see this is the wall composition over here. Then we have sand cement plaster over here, then we have brick. So sand cement plaster over here this side, and sand cement plaster, its thickness is 0.013, so 0.013 divided by its thermal conductance value. Plaster conductance value is 8.65, so 13 divided by 8.65, 13, convert this into meter, 0.013 divided by 8.65. Then the next one, we have this after plaster we have the brick over here, and brick thickness is 230 mm, that is 0.23. so 0.23 divided by thermal conductance of the brick, that is 0.77, so 0.23 divided by 0.77. and then we have the air gap over here, that is Ka. So 1 divided by Ka in this formula. So 1 divided by Ka. Ka value is 5.5. You can see the thermal conductance of the air gap is 5.8. And then we have this again, we have a brick over here, then sand, cement, plaster, and then inside film coefficient here. So brick first, 230 mm. 230 mm divided by 1000 divided is equal to 0.23 meters the thickness, divided by thermal conductance of the brick is 0.77, plus then we after brick we have this cement over here, and cement thickness is 0.013 meter, divided by thermal conductance of the plaster is 8.65, plus 1 divided by Hi. Hi is the inside film coefficient and its value is 8.5. So 1 divided by 8.5. So we have applied all the values over here. So after putting all the values, U overall heat transfer coefficient U of the wall is calculated as 1.07 watt per square meter Kelvin. As you can see, if I double click, I already applied the formula here. So this is how you can calculate the overall heat transfer coefficient U value of the wall, and this is for outside wall. So next is I will show you, it is the same procedure, but still I will show you the inner wall partition wall U value calculation. So as you can see that our interior or partition wall consists of 230 mm common brick with 26 mm 13 mm sand, cement, plaster on both sides. So in this case there is no air gap, we have just outside film coefficient, then sand, cement, plaster, then brick, and then sand, cement, plaster, and then we have this inside film coefficient. So this, there will be no there's only one brick over here. You can consider this part only, like outside film coefficient, sand, cement, plaster, then the brick, and then sand, cement, plaster, and then we have this Hi inside film coefficient. This is not here. So same formula which we are going to use over here. So 1 divided by 1 by H0, outside film coefficient value 1 divided by H0, that is 8.5. you can see over here outside film coefficient. Outside film coefficient is over here, that is 23. Sorry, this is 23. One divided by 23. So plus we have cement thickness over here, that is x divided by k1. Cement thickness is 13 mm on this side, one side, and 13 mm on the other side. So 13 mm, convert this into meter, you will get is 0.013 meter, divided by thermal conductance of the plaster, that is 8.65. so inside film coefficient is outside film coefficient is done, then we have sand, cement, plaster is done, then we have a brick, and then sand, cement, plaster layer. So brick thickness is 230 mm, just one brick, so 230 divided by 1000, that is 0.23 meter, divided by thermal conductance of this brick is 0.77. you can see 0.77 thermal conductance of the brick, plus cement on the other side, that is 13 mm, divided by thermal conductance of cement is same 8.65, plus 1 divided by Hi inside film coefficient. Inside film coefficient is 8.5, so 8.5 over here. So this is how you have to put all the values, and you will get the inside wall U value or partition wall U value, overall heat transfer coefficient. So as you can see that this is the formula I have already applied here. So after adding all the values in here, you will get the overall heat transfer coefficient U value of the inner or partition wall is 1.86 watt per square meter Kelvin. So this is how you can calculate the overall heat transfer coefficient U values. In the same way you can calculate, if you know the material for the roof, floors, doors, you can calculate the U values for every single material, because these values, U values, overall heat transfer coefficient, these are the things we are going to use in our HVAC system design. While we are designing our system, this is very important parameter that needs to be calculated first, to calculate the heat transfer, to calculate your heat loads. So in the last video I told you about psychrometric chart, and in this video I told you about the overall heat transfer coefficient U values. So these things we are gonna use in next videos to calculate our heat load for some particular project. So I hope you guys learned something from this video. For more videos, keep watching my channel and don't forget to subscribe. Thank you. Bye.